You're struggling to control your sugar levels. Aish. The explanation for the problem? Well, you're insulin resistant. The insulin you're pumping out isn't working. Specifically, the cells that are meant to spring into action when insulin arrives on the scene ignore insulin's pleas. And the ignoring means that the glucose gates, which are stored deep inside of the cell and only moved when a glucose delivery is expected, aren't translocated from the inside of the cell to the outside of the cell. And this is a big problem. No glucose gate means the sugar can't get in, and sugar levels rise while cells go hungry. Unfortunately, when you have lots of sugar molecules with nowhere to go, they end up damaging blood vessels. So getting those glucose gates translocated is important. Join us for this episode of Better Body Chemistry TV as we discover how to get those glucose gates up so you take up more sugar. Better Body Chemistry TV is brought to you by Dr. Sandy, a scientist turned gremlin buster, helping you battle sugar gremlins, heffalumps, and other health horribles through better body chemistry. Remember, small things can make a big difference to your health. So, what does it take to move the GLUT4 gate from deep inside of the cell to the surface? Well, duh! Insulin! This is why the fix for high sugar levels is to send in more insulin. But there is a caveat. The insulin you're sending in needs to actually arrive at the cell taking the sugar delivery. And when you're insulin resistant, this can be a problem. You see, getting insulin delivered depends on endothelial cells being responsive to insulin. But when you're insulin resistant, they're not. So delivering insulin becomes the problem. You see, to get insulin delivered, you need good blood flow. And good blood flow depends on nitric oxide levels. And nitric oxide release depends on insulin. Aish, you're in a pickle. Inspired by this observation, a team of researchers from Texas wondered if improving nitric oxide levels might help get the sugar delivered. Knowing that the body has more than one way to make nitric oxide, they hatched a plan to increase nitric oxide delivery using sodium nitrite, a molecule that can be chemically reduced in the body to form nitric oxide. They gathered 8-week-old mice, genetically programmed to be diabetic, and then tossed a little sodium nitrite, 50 milligrams, into their drinking water, and they watched what happened. 28 days later, they found that the mice sipping sodium nitrite were in much better shape. Despite eating the same amount of food, the animals were significantly thinner, and their diabetes wasn't quite as bad. The animals' fasting glucose and insulin levels were significantly lower. This result confirmed the connection between nitric oxide and insulin activity. But it didn't explain the details of the relationship. So the team set about understanding how the nitrite had helped. What did the nitrite do? First off, they tested to see if the benefit was because of better blood flow. To do this, they isolated bits of aorta. This is the main blood vessel, and tested how well it contracted and relaxed outside of the body. There was a small improvement in the performance of their aorta following the sodium nitrite exposure, but it wasn't big enough to matter, so they kept looking. This is when they discovered the nitrite is involved in moving the glucose gates from the inside to the outside. Using muscle cells in a dish, they tracked fluorescence patterns. This photo shows a typical reaction. The blue dots are myocytes or muscle cells, and the green fuzz is where a fluorescent antibody that recognizes the GLUT4 gate has bound. Now, in ordinary cells, the control, the glucose gate is buried deep inside, so the fluorescent antibody has nothing to attach to. But when either insulin or nitrite are added, the glucose gates end up on the outside where the fluorescent antibody is able to lock onto it, creating the green fuzz. From the photo, you can see nitrite caused the glucose gates to move without the help of insulin. How could this be? Well, when insulin binds to the insulin receptor, assuming there are no problems with insulin resistance, it activates the enzyme known as endothelial nitrogen oxide synthase, or ENOS for short. Now, this enzyme turns L-arginine into nitric oxide. The released nitric oxide moves the gate. Not literally, it's through a signaling system. The team found that the nitrogen oxide popped a nitrogen onto the gate. This S-nitrosylation reaction was the signal that got the gate moving because the cell now knew a glucose delivery was imminent. So, what does this mean for you? Well, if you are insulin resistant, you're low on nitric oxide. But if you're low on nitric oxide, you're going to be insulin resistant. It's a catch-22. However, if you could find a way to bump up the nitric oxide levels, you will improve sugar deliveries. So, how do you do this? Well, you don't need to add sodium nitrite to your water, and probably you shouldn't. The nitrite is harmless, but it can combine with secondary amines under certain conditions, forming nitrosamines. And nitrosamines are classified as carcinogens. But all is not lost. There are a couple of ways to boost nitric oxide levels naturally. These include physical activity, sun exposure, and eating your greens. In fact, eating your greens is seriously efficient and easy to do. Green leafy vegetables like spinach, chard, lettuce, as well as beetroot are rich in nitrate. Now, it turns out some of the nitrate you eat gets shipped to your mouth. The rest of it gets peed out. the nitrate that ends up in your saliva gets worked on by the bacteria living in your mouth. They use an enzyme, nitrate reductase, to turn the nitrate into nitrite. These little guys can provide you with somewhere between 40 and 100 milligrams a day. The catch? You need to supply them with nitrate. That is, you need to eat your greens. What they supply should be more than enough to get that glucose gate translocated, giving you better body chemistry. Interested in discovering more ways to create better body chemistry, or need a little help getting your body chemistry on track? Visit our website at www.betterbodychemistry.com. Browse our library and sign up for our newsletter. The advice is simple to follow and based on real science, not hype. Know someone who's struggling to keep their sugar levels under control? Share this video with them so they know that slapping a nitrogen group on the gate will help get it moved to where it needs to be to keep those sugar levels in check. And if you enjoyed the video, be sure to subscribe to our channel so you catch future episodes of Better Body Chemistry TV. Thank you so much for watching, and I'll see you next time. Remember, small things can make a big difference to your health.